Hello everyone. So the purpose of this tutorial is to show you guys the basics of using a 3D printing slicer software. Um, and I'll be going over a little bit about some of the main features in the slicer software that you should be worrying about. And basically I'll go through how to start your first print. So the software that I'm using today is called Cura, but at the DME they use a software called Octoprint. Which is not exactly the same. However, a lot of the features are similar, and so they sort of translate to Octoprint as well. So really, if you know what each main feature does and how to configure them, then you should have no problem doing the same thing for Octoprint. Okay, so I'll go ahead and open our STL file. So I'm just going to go ahead and open the bell crank design, which is already exported as an STL file. And then I'll talk about these main features. So at the DME, there are really only 4 parameters or settings that you need to worry about, and that's infill, temperature, supports, and build plate adhesion. So let's go ahead and start with infill. Now infill is sort of the support structure that makes the inside of your 3D printed part. A lot of the times your part is not fully solid, and so there has to be some sort of support structure inside of it to keep it stable. And so that's what infill is. Now there are really only 2 things that you should worry about with infill, and that's infill density and infill pattern. At the DME, they have pretty much set rules for these. For instance, the infill density is at a maximum of 20% at the DME, so they won't allow you to print a part with an infill density above 20% there. So that's something that you need to keep in mind. Also, there's infill pattern, and the default infill pattern at the DME is grid, I believe. And let me show you guys what that looks like. So if I click grid, yep, and then I go slice my my part, and then I go to preview mode. So this is a view of every layer of my 3D printed part as it's getting printed on the 3D printer. Now if I just drag down the slider, it'll show me every layer that's built on my part. So I'm zooming in. So you see these structures inside. This is actually what my infill is. And right now I have an infill pattern of grid. So that's why it looks like that. See, if I were to change it to, let's say, triangles, and I were to slice it again, see how the infill pattern changes? So there are different advantages to each of the infill patterns, but I won't really go over that in this tutorial because I already covered it in the presentation I did before, so you can always look at that presentation again. Okay, so let's move on to temperature. So printing temperature and build plate temperature are directly dependent on the type of material that you're printing with. For our purposes, we're either printing with PLA or PETG, and each one has a different printing temperature and build plate temperature setting. So for PLA, you generally want a printing temperature between 180 to 210 degrees Celsius. But when you're printing at the DME, the recommended printing temperature is actually 210 degrees Celsius. Oops, there's an extra 0 there. 210 degrees Celsius and a build plate temperature of 70 degrees Celsius. Now when you're printing with PETG at the DME, their recommended setting for printing temperature is 245 degrees Celsius and a build plate temperature of 90 degrees Celsius. It's very important to make sure that the temperature settings that you have are correct for the type of material that you're printing with. Because if you were to have incorrect settings for the temperature, that could directly lead to your part failing to print. Okay, so now let's look at supports. Supports are very important, especially when your part has overhangs, bridging, or any sort of structures that might not have enough initial layers to build on top of. So let's take this bell crank for example. Now the way it's oriented right now, it has overhangs and a lot of areas that would definitely need support because they don't have an initial layer to be built on top of. So for instance, if you look at the bottom of the part, you have two overhangs on an angle, which will definitely need supports if you were to print it this way. And also if you look at the cutouts on the part, that you can see the red areas, which tells you that these areas will need support when being printed because they don't have an initial layer to be built on top of. Okay, so let's go ahead and click Generate Support. Now you see that there's a couple different options here. So let's look at Support Placement. Now if you click this drop down menu, there's Touching Build Plate and Everywhere. So let's talk about these two different settings. Touching build plate means that the slicer only puts supports on the areas of your part that will be touching the build plate. So it only builds supports where one end of the support is touching the part and the other end is touching the build plate. Let me show you guys what that looks like. So if I were to slice my 3D printed part as is, and let's click the preview mode. So you see here how the blue supports are only built in the areas where one end is touching my part and the other end is touching the build plate. Technically, these cutouts should also have supports, but because we click touching build plate option only, the supports will only be built in these areas. Now if I were to click everywhere and then slice my 3D printed part again, now you can see that the blue supports are also built inside of these cutouts, which technically should have had supports. So let's go back to our regular view. So now let's look at support overhang angle. Now what this angle is it's the minimum angle at which the slicer starts to build supports for your 3D printed part. And you can manually change this. So right now it's set at 47 degrees. And if I were to click preview again, so these supports are here now because the overhang angle is over 47 degrees. But let's say we were to change this to 80 degrees and slice the part again. See now how the angles on the bottom don't have supports. This is because the overhang angles on the bottom are below our minimum angle of 80 degrees. Okay guys, so let's move on to our final setting, which is build plate adhesion. And essentially what this setting does is it allows you to keep your print on the build plate. Because if your part were to come off of the build plate at any point of the 3D printing process, again, that could lead to print failure. So let's go ahead and click this drop down menu. And you can see there are a few different options, skirt, brim, and raft. Let's talk about each one. So let's go to skirt. And I'm gonna go ahead and slice this part. Preview mode. Okay, so what a skirt is it's a single layer of outline right outside of your 3D printed part. And usually this is used to prime your extruder and to verify that nothing is wrong with your filament or printing temperature settings. Essentially to test your extruder and see if there's any problems right before printing your actual part. Okay, so let's click the next one, which is brim. I'm gonna slice the part again. Alright, so a brim is basically a skirt, except it actually touches your part and keeps it on the build plate. Whereas the skirt was just an outline and doesn't actually keep your part adhered to the build plate. So a brim is a single layer of filament that outlines your part and touches the edges of it. This is the most common type of build plate adhesion method, and it's usually the best one to use because it doesn't use as much filament, yet it keeps your part adhered to the build plate. You'll see when we talk about the raft. Let me slice this. Okay, so the raft is kind of like the brim, except it uses multiple layers. And so this takes the most time to print, but it does provide the most adhesion for the build plate. However, it's not a very common option to use because it does use a lot of filament, and most of the time it's unnecessary because the brim should be sufficient to keep your print on the build plate. Alright guys, so those were the 4 main parameters or settings that you should be looking into when 3D printing at the DME or just 3D printing in general. So after you've set those parameters, in order to actually start printing, what you want to do is slice your part like I did before. So you've already set all your parameters, your infill, temperature, supports, and build plate adhesion. You want to slice your part. And what I would normally do is, because my printer uses an SD card, I would plug the SD card into my computer. Alright, so now that I have my SD card plugged into my computer, I click Save to Removable Drive, and then Eject. Now all I have to do is plug my SD card into my 3D printer, make sure that the temperature settings are correct on the printer, and then start printing. Just as a final note guys, this tutorial was only to give you guys a basic understanding of the different parameters that you should be looking into when using your slicer software, but there are other things that you need to consider when printing at the DME, and you will learn all of that when you take the 3D printing certification there. So I do suggest that you take the 3D printing certification at the DME when you have time, because you guys will definitely learn a lot more than what I taught in this tutorial.